Now let's look at iterators and custom generators. So let's start with iterators. What is an iterator? Iterator is an object that contains a countable number of values. An iterator is an object that can be iterated upon, right? Meaning that you can traverse through all the values. Technically, in Python, an iterator is an object which implements the iterator protocol, which consists of a method iter, iter, and next, which tells you what is the next value in the iteration. Now, the difference between an iterable and an iterator, right? So list, tuple, dictionary, and sets all are iterable objects. They are iterable containers which you can get an iterator from using the iter method or function. All these objects have iter methods which can be used to get an iterator. Now let's look at it in action. Let's start with a simple example without an iterator. Let's say I have a list 1, 2, 3, 4, 5, 6. We can print that list M for I in M. We can print I. Let's clear the screen, run it, and see. See? So there's nothing new here. But what you can say is that we have a list M, and I'm iterating through the list M, and for every iteration, the value of I changes to the next one, right? Now let's do the same thing in a different way. So what I'm doing is I'm creating an iterator for M. And how do I do that? I use iter method. Now there is a next method. Next iterator M. And I can do this again and again. And we have done it 6 times because we have 6 values. Let's run it and see what is the results. It works. But what if I call next once more, 7th time? We have only 6 items. See? So what happens is that when I call next, when there's no item left in the list, as we iterate through it gives me an exception, stop iteration. And of course, next provides us with an additional argument, which is the default value when the stop iteration exception happens. Let's say we call it end of sequence. And let's run it again. And we could have added this default value all along. Or maybe we should do it. We just need to make sure that we are doing it more than 6 times. I think it has happened. It is more than 6 times. Let's run it again. See? So what has happened, right? So whenever we have an iterable object like a list, dictionary, set, and so on, we can create an iterator of that iterable using the iter method. And we can use that iterator object and next function to get next value again and again. This is an example of iterator. Let's do it more efficiently using a loop. So here we can remove this. So we have a list M, we create an iterator. Let's say the first value is I, which I get from next of iterator. Now we do it forever while true. We print I, we try I is equal to next. iterator. Now what happens, right? So in the try block, we just try to do our thing, which is we're trying to look for the next value. If there is an exception, we handle it. And because there's an exception, there's no value left. So we break the while loop. Let's run this. See, it works successfully. And we are just running it till the end, right? This is nice. Now, let's say I wanted to build a custom iterator. So let's clean this up. Let's say I create a class, call it my numbers. So I define my iter magic method. So let's say self.a is equals to 1, return self. We have also defined our magic method next. Self. We have x is equals to self.a. Self.a is equals to self.a plus 1 return x. So this small class is our custom iterator, and of course it whenever we call iter function, it uses this function dunder iter dunder. Whenever we call the next function, it uses undunder next dunder method. So let's see that in action. So first I create my object, my class is equals to my numbers, my iter is equals to iter of my class. So we have created an iterator. Now what we can do is we can print next of my iterator. We can do this a few times. Oops. We can do this a few times. Let's run it and see. See, it works. Now, our function should also have a way to stop iteration, right? If I would have run or iterated on this object, it would print these numbers or return these numbers forever. We don't want that. So we modify our code in such a way that there's only a limited number of times we can call next. So how do we do that? Let's say we just want to do it 20 times. We have self.a is less than equals to 20. If that happens, we do our things. Else, we raise an exception, stop iteration. This is all fine. Now, let's try to run it in a loop for x in my iteration. My iter print x. Now we can see, let's clear screen, run it, and it prints numbers 1 to 20. And this is what we were designing our iterator for. So this is how we build our custom iterators. So this is all about iterator. Previously, we were looking at a function called reduce, right? Let's look at it again and understand it in depth. So let's do that. Let's clear it all up. It's just a nice use case of what we learned. So let's first import reduce from func tool, import reduce. Let's say L is equals to some random numbers, 4, 2, 6, 1 is fine. Now we want to print S. And what is S? It's sum which is calculated by using reduce. Reduce, the first argument is a lambda function, x comma y, x plus y, then L. This is it. We should get our results now. We get 13. 6, 4, 10, 12, and 1, 13. That's correct. So this is the reduce function, right, which we imported. Just for the sake of experiments, okay, let's try one more. Let's say I wanted to find the max. So if x and y are two arguments, we return x if x is greater than y. If that's not true, I will return y. And it's not hard to imagine why this should give max, right? Because we are constantly keeping track of the max in first argument, and we are always we take the next value, and we are always returning the max of the two values and I keep iterating, right? So this should give us the max, which is 6 in this case. 6. See, no problem here. Now what I wanted to do is go to Python documentation. Let me do that. We go to Python documentation. Okay, I will just have the link here. Let's clear this up. So the link I pasted in the screen in the comments, right? If you go to this link, you will see a Python version implementation of the reduce function. So I'll just paste it here. So let's understand this first and then run it. So what is a reduce function? The reduce function takes 3 arguments, and we have done it before. It takes a function which helps us find whatever operations we are interested in. There's an iterable like a list. There's an initializer which tells you the starting value. So we create an iterator out of iterable object. If initializer is none, we just take the next value of the iterator. If it is not none, we take the value of the initializer to begin with. Then we go through each element in the iterator. We use the function and we track the running value and the new element in the iterator. And we finally return the value. Okay, this is my reduce function in Python. Of course, it's just to understand. Now let's say I have a list of items. Again, some random numbers 2, 4, 6, 1, which was, I don't know, maybe it was the same. Now S is equals to reduce. I hope I've removed everything. Yeah. So we define reduce ourselves. So S is equals to reduce lambda x comma y, x plus y, and L. And let's say the starting value is 6. Let's run this. Okay, we have to print it also. We print S. So the sum is 19, starting with initial value 6. So 6 plus 4, 10, 12, 13. So sum of L is 13. 13 plus 6 is 19, which is correct, right? So it works, and we have understood really how reduce works. We have used lambda functions to define this function. We have used iterable, we have used next, and everything comes together nicely. So next we move on to generators. So now let's look at generators. So the main thing about custom generator is the yield keyword. So let's look at how we can create a generator. Let's say we have a function alphabet sequence with a limit. Now for I in range 65 to 65 plus limit. So 65 is the alphabet A. Then we'll just use a keyword called yield, and then we'll return the character value for I. Now let's create a generator. So let's call our generator alphabet gen. Let's initialize it. Let's say the limit is 5. Let's print. So in generators also next keyword is something which is used, and it's very similar to iterator. So let's print this first and see what we get. We get an A. And let's say we call next 5 times. We can see it will print us sequence of alphabets A, B, C, D, E. And if we do it one more, we get an end of sequence thing. See, it prints the first 5 alphabets, then we get a stop iteration exception. And that's fine. That's by design, right? And we could also have a default value which says end of sequence or something. Let's run it again. See, it says end of sequence. So what is happening here, right? So we defined a function, and there's this new keyword called yield. So yield is very similar to return. In return, you cannot go back. It returns a value and it's end of the function. There's no execution after it. In yield keyword is more like a pause. So what happens is it will return whatever we want to return, and whenever we call next again, it continues from there. So it remembers the state of the function where it returned and it continues. So that's the difference between return and yield. So let's look at one more example. Let's clear this up. Let's say I want to create a generator for even numbers. So we can have, let's clear all this up. So we are creating a generator of even numbers. So simply said, we just run a loop to compute even numbers again and again, and we use the yield keyword to return the state we want to return. While true, so we run this forever, yield number, and then num plus is equals to 2. So this is just a shortcut of saying num is equal to num plus 2. You can also write num plus equals to 2. So we have created our generator. Let's say we have our even generator. We initialize our even numbers generator. So now let's say I wanted to print first 5 even numbers. For in range 5, we print next even gen. This is it. So what have we done, right? So basically we define an even number generator. So it's just a function, but it is called a generator because of this yield keyword. So we initialize num to 0, we run the loop forever, and we keep returning number plus 2, number plus 4, and so on, again and again and again. So it will return 0, 2, 4, 6, 8, and so on, right? And yield is something which returns the value of num. But when we call next again, it remembers the state of last time when it returned. So it continues from there. So let's clear the screen, run it, and see it runs for 5 times because range 5, and this is our generator. So I hope generator is kind of clear. So we can do one more thing for generator. So first is, let's create a new file here. Let's call it data.csv file, and let's say I just have line 1, line 2, line 3. That's it, 3 lines. Let's clean this up. So yield is also useful in a way that, let's say I have a very large file, like let's say 10, 50 GB files, right? We don't have enough RAM to load that 80 GB file, right? So what we can do is we can open the file and read one line at a time. So we can see an example. I'll just type it. So we write a generator, which is like, let's say, data feeder, file name, for row in open file name in read mode. Then we read the row. That's it. So we just created a generator which gives us one line at a time. So let's create our data generator, which is our data feeder, then the file name, which is let's say data.csv sample count equals to 0 for row in data gen sample count plus equals 1. Print sample count. So what can we see here? We created a generator, we read the file, and we return one line at a time. And while doing that, we just count number of lines. Of course, we could operate on the line as well, but we just want to count the lines for now, just to show that we can have a use case of generator. See, we had 3 lines in the input file, right? We had 3 lines. This kind of works. So generators is a powerful way to handle very large streams of data. In the next video, we will look at generator pipelines, and there we will really see the power of generators.